Hello, my name is Dr. Rahil Joshi, and today I'm presenting the work on wearable textile-based transmission line. This work was done in collaboration with the University of Edinburgh, Hereford University, and J&D Wilkie in Scotland. Now, over the decades, there has been a lot of work which has been focused on wearable textile fabric and material, especially to incorporate within the wearable devices such as flexible circuits, electronics, and wearable antennas. However, these research are focused mainly on wearable antennas, and there is hardly any literature work which is available on the feeding network. In radio communication, the feed line works as an important component both at receiver and transceiver, and because it acts as a transmission line. Therefore, in this work, we introduce an new and innovative flexible textile-based transmission line, which is compact, robust, flexible, and achieves a 50 ohm characteristic impedance. Over here, you can see our prototype, which is a 10 centimeter long. It's textile-based, and it is developed for military search and rescue operation, Wi-Fi application, and other wearable devices. Now, we have used an coaxial cable, classic coaxial cable structure, where in a standard coaxial cable you have 3 layers. One is center conductor, which is metallic. Then the third layer, the dielectric layer, which acts as an insulator, and the third layer, which is in metallic again. Now, in the proposed coaxial transmission line, you have for layer 1 as an metallic layer, which is constructed with 50 tightly pieces of the copper yarn. The dielectric layer over here is a PTFE material, which is purely textile-based material, and the layer 3 is an hybrid material, which is copper twisted together with a textile material. We over here used a braiding technique, which helped us to achieve a flexible and lightweight configuration. We measured the performance of the weight of our proposed coaxial cable with the commercial cable, and it was 30% less weight than the commercial cable available. We have also measured the performance of our cable using the S parameter measurements, and it was, you can see over here, the simulation are in agreement with the measurement, and it's below -10 dB. Because this is developed for the wearable application, the robustness test and such as bending and wet tests which have been performed, and you can see the performance over here. They are fairly well matched and are below -10 dB. In the wet test, you lose the performance when the cable is when the cable is wet, but then it regains its performance when it's dry. So in conclusion, we have introduced a new and innovative coaxial textile-based transmission line, which is novel, and it could be incorporated in the new communication system devices for various applications up until 6 gigahertz.